Again a question from sequence. It is given that A, B, C are in GP with a common ratio R and R is varying from 0 to 1 by 2. If 3A, 7B and 15C are the first three terms of an AP, then the fourth term of this AP is. Now ABC here are given in GP. So we are assuming ABC as A, AR and AR square. So 3A, 7B. So B is AR because ABC are in AP, and 15C, that is 15AR square. Now these three are in AP, it is given. So definitely 2B, that is twice of the second term, is equal to first plus third term, that is 3A plus 15 AR square. You can see here A is cancelled out, and if you calculate the value of R, that will come out to be 1 by 3, which is lying in this interval. There is other value as well, but it is not lying in this interval. So this is the only valid value. So R here is 1 by 3. So we know each and every term here. So first is 3A, second will be 7A by 3, and definitely the third will be 15A by 9. Now these three are in AP and we want to find out the fourth term. This can be easily done. If you calculate the difference, that comes out to be negative. So the difference you can calculate from here, and the difference you will get is minus 2A by 3, and by finding the fourth term, which is equal to A plus 3D, but A here is not A, the first term is 3A. So 3A plus 3 into the common difference, which is minus 2A by 3. Now finding out this will give you the value 3A minus 2A, which is again equal to A. So the correct option here for us is the second one. Let us move to the next problem. Here's the much awaited problem on area. Finally, we see an part which is again an easier one, the tracing of curve y is equal to 2 raised power x and y is equal to mod of x minus 1 in the first quadrant. So we have to find out the area bounded by these two curves in the first quadrant. So first we have to draw the figure of y is equal to 2 raised power x, which is the exponential function, and again the modulus of x plus 1. So here is the figure for us, which is an easier one to draw. So what is the figure? Now figure is, this is the exponential function which you can see, and this is the modulus of x plus 1, which is making a turn at x equal to minus 1. This is origin, and if you notice that these two curves are meeting at x equal to 0. So this is the point 0 comma 1, because at x equal to 0 you can see y is 1, and again at x equal to 0 you can see y is 1. There is one more meeting point where we have to check, and by hit and trial, because you won't be able to solve this at x equal to 1, again you can see here y is equal to 2, and again at x equal to 1 you can see here the y is equal to 2. So there is another meeting point, and this is 1 comma 2. So there are two bounded areas. One is this one that is lying in the second quadrant, and this is the first quadrant area. So we have to calculate. It is clearly given in the problem that the area which is lying in the first quadrant. So this is the required area bounded between these two curves. So what we have to do, we have to integrate. So you know the required area is integral from 0 to 1. It is the upper curve. The upper curve is the modulus 1, that is equal to mod of x plus 1, minus the lower curve, which is 2 raised to the power x, integrating from 0 to 1. Now opening this modulus sign is an easier one, because you are going from 0 to 1. So this will be opened with the positive sign. So we have this integral, and you know the integration of this function is easier one, and if you integrate it and keeping the limits here will give you the value 3 by 2 minus 1 by log 2. So, the first option is the correct option. So, here tracing the curve and finding the intersecting point is the trick. Next question is again from 3D. A perpendicular is drawn from a point on this line to this plane such that the foot of the perpendicular Q also lies on this another plane. A good question to work with. So, we need to first draw the figure. We need to understand the figure first. There is a point, there is a variable point on this line. It is not a fixed point from which a normal, a perpendicular is drawn to this plane, and that point is also lying on another plane. So, that point is Q. Now, what are the coordinates of Q? So, let us have the figure first here, what is given to us. So, you can see this figure clearly. This is a plane which is the first one, that is x plus y plus z is equal to 3, and this is a line, this is the line, and from any point on this line a perpendicular is dropped, and this is the point Q. We have to find out the coordinate of this point Q. So, let us first assume this to be alpha, beta, gamma, and this point P which is lying on this line equating this to lambda. You can see from here, assuming a point x will be equal to 2 lambda plus 1 and y will be equal to minus lambda minus 1 and z will be equal to lambda. So, this is the point, variable point on this line, and Q is lying here. Now, what is given to us? This alpha, beta, gamma I have assumed on this plane. So, definitely have to satisfy this point on this plane. So, we have the first equation, that is alpha plus beta plus gamma is equal to 3, and also this point is also lying on the next plane. So, we need to satisfy here as well. Now, from these two equations, if you add these two or subtract these two actually, so beta will be equal to 0, and adding will give you one more equation, that is alpha plus gamma is equal to 3. Now, the beta is known to us and alpha plus gamma is equal to 3. Now, what next? We haven't used the concept of perpendicular, that is PQ is perpendicular to this plane. So, definitely the direction ratios of PQ and the normal to this given plane will be same, or you can say their ratio will be same. So, the direction ratios of PQ are what? The direction ratios of PQ here are, let us see that is alpha minus 2 lambda minus 1, and again beta minus this. Now, the beta is 0. So, it is lambda plus 1, and the third one is gamma minus lambda. Now, these are the DR or the direction ratios of PQ, and the direction ratios of the normal to the plane x plus y plus z is equal to 3 is 1 1 1. So, the ratios of the direction ratios will be same. So, we have another link here which is linking this alpha, lambda and gamma. So, from here you can calculate the value of alpha in terms of lambda. So, alpha you will get from here 3 lambda plus 2, and beta definitely we have calculated as 0. Now, gamma is equal to from here 2 lambda plus 1. Now, how to get lambda? If you get the lambda from here, you will be able to calculate the alpha, beta and gamma. There is a link which we have calculated. It is alpha plus gamma is equal to 3. Now, putting these two values here, we have 3 lambda plus 2 lambda plus 1 is equal to 3, and from here you can see lambda is equal to 0. So, by putting lambda equal to 0 here and here, you can see alpha is equal to 2 and gamma is equal to 1. So, the required point here is 2 comma 0 comma 1, because beta is 0, that we have already calculated. So, the correct option here for us is definitely the second one. Let's move to the next problem.